Hi, welcome to Make 2 Explore. In our previous video, we showed how to set up OpenThread Border Router on Raspberry Pi with a Nordic's nRF52840 dongle. In this project, we will use that setup to build a thread network. Then we will program two ESP32 boards as thread-based smart lights, means as an accessory devices. These thread-in devices will form thread mesh and get connected to rest of the smart home network via OTBR. Then with an Amazon Echo as the Matter controller, and by sharing the thread network key through the Alexa app, all devices securely join the same network, so we can control the thread lights seamlessly with Alexa. So let's get started. Please note, the goal of this video is to understand the thread network and working of OpenThread Border Router. So first, let's see the concept and the components. This is a conceptual diagram of our practical setup. It will consist of thread network, formed with thread devices. We will be using these two ESP32 dev boards, C6 and H2. Then, this border router connects thread mesh to rest of smart home network, which will consist of smart home controller. So, these are main four components. ESP32 Thread Light devices, Raspberry Pi as an OTBR, Wi-Fi router of your smart home, and Amazon's smart speaker Echo. Let's see all this in detail. Here's the full practical setup of our project with all hardware. Let's see one by one. So, in this experiment, we are using a Raspberry Pi paired with an nRF52840 dongle to act as the OpenThread Border Router, OTBR. For the thread accessory devices, we have two ESP32 boards, ESP32C6 and ESP32H2, each programmed as a Thread Matter Light application. On the controller side, we're using an Amazon Echo smart speaker connected to the home Wi-Fi router and the Alexa app running on a smartphone to provision and control the devices. Together, these components form the complete testbed for building and demonstrating a real Thread Matter smart home setup. When we power up our two ESP32-based devices running the Thread Matter Light application, they're designed to work as part of a thread mesh network. But unlike Wi-Fi, a thread network isn't just open. It requires a secure network key to join. That's why we first set up an OpenThread Border Router, which creates the thread network and generates that unique key. The ESP32 devices join this mesh over the IEEE 802.15.4 radio. Once they join, they become controllable thread lights, waiting for commands, but not yet visible to Alexa on their own. Then, the OTBR bridges the thread world with the home's Wi-Fi network. The OTBR itself is connected to the home Wi-Fi router over 2.4 GHz Wi-Fi, IEEE 802.11. This makes it as the translator. It allows devices on the Wi-Fi side, like the Amazon Echo smart speaker, to discover and communicate with the thread devices securely. Without this bridge, Alexa cannot directly talk to the thread lights because they're on a different radio protocol. Finally, when we open the Alexa app on a smartphone and try to add those thread lights into the smart home control, it asks us to connect to that existing thread network by providing the thread network key, which we got from the OTBR setup. So, once we enter the keys, Alexa can discover the Matter-enabled thread devices through the Echo smart speaker, which uses Wi-Fi to reach the OTBR and then Thread to reach the ESP32 lights. From that point on, voice commands like Alexa, turn on the light, go from your smartphone to Wi-Fi router, then via router to Echo speaker, then speaker to OTBR, next OTBR to thread mesh, then finally to ESP32 Thread Light. This seamless flow of different wireless networks is what makes Matter and Thread powerful for smart home automation. So this was about theoretical working of our experiment. Now let's see the actual demo. Let's first program these ESP32 devices with Thread Matter Light application. For that, we will use web-based tool given by Espressif Systems, which is nothing but the ESP Launchpad for Matter. If you recall, we have used it already in our previous videos. Let's see. Just follow along and see how we do it. First, go to any Chrome-based browser. Since we know that ESP Launchpad makes use of Web USB to communicate with the device. Hence, this tool currently only works for Chrome-based browsers. This tool is not supported on Safari and Firefox browsers yet. This is the interface. Now let's connect our ESP board. Okay, so as they said here, ESP Launchpad helps you to flash the selected firmware image onto your device. Ensure you have connected your device to the serial USB port. Click on the Connect button in the top menu option to connect to your attached device. Let's do that. So, here is that Connect button in these top menu options. Click on it. New pop-up window will get open, asking you to select the serial port of your ESP32 device. Select correct port and click on the Connect button. Once your ESP device gets connected, you will see its name here, like this. In our case, the ESP32C6. Next, as they said here, choose from some of ESP's pre-built, out-of-the-box examples to flash and play. So in this drop-down, you will see different pre-built applications. These are all different Thread and Matter applications which we can flash onto this ESP board or ESP chipset type. If you change application, you will see its supported chipsets appear below, like this. So, at the time of recording this video in September 2025, there were 9 applications listed on this platform. These may change as per the updates in ESP IDF and ESP Matter. You can refer these commit hashes for application build configurations related to IDF, Matter, Chip, and Rainmaker. Okay, now let's see about the application which we are going to use for this experiment, which is Thread Matter Light. Please note, it is different from this application, Wi-Fi Matter Light. This uses Wi-Fi. And this one, Thread Matter Light, use Thread Radio. The difference is underlying wireless radio standard and protocol, which is Thread and Wi-Fi. Okay, now let's flash this Thread Matter Light application into ESP boards. So, as we've seen earlier in block diagram setup, we're going to use these both chipsets, C6 and H2. Just follow along with us. Okay, now as we have flashed both ESP32 boards with Thread Light application, next part is creation of thread network using OTBR. For that, let's remotely log into our Raspberry Pi using PuTTY via SSH and set up new thread network through command line. On our GitHub repo, we have shared a detailed reference guide for testing a thread network with OTBR and ESP32 devices. Let me show you. So you can see, This guide outlines the steps to set up and test a thread network using a Raspberry Pi running OpenThread Border Router, OTBR, two ESP32-based thread-end devices, ESP32C6 and ESP32H2, and Amazon Echo as a smart home controller. These are overview of steps. Let's create and start a thread network. In Terminal, launch OpenThread CLI. Then, create a new network dataset. You can use this command to view the dataset parameters. Then, very important, using next commands, you can customize network settings. You can change parameters such as the channel number or network key. You can change network key as per your choice. But remember, the thread network key must be exactly of 16 bytes, 128-bit. So, the thread network key is what keeps all devices in the thread mesh securely connected. It's always a 128-bit key, which means it has to be 16 bytes long. And when we enter it in tools like the OTBR or Alexa app, it appears as 32 hexadecimal characters. Hence, by sharing this same key, every thread device, like our ESP32 smart lights, the border router, and the Alexa controller, can securely join and talk on the same thread network. Then, this OpenThread CLI command, dataset channel 11, is used to set the thread network channel to 11. In simple terms, a channel defines the specific slice of the 2.4 GHz wireless band that thread devices will use to talk to each other, similar to how a TV picks one channel to show a program without interference from others. Thread typically uses channels 11 to 26, and by setting the channel, we ensure all devices in the same network are tuned to the same frequency so they can communicate reliably. Then finally, using this command, we will commit the dataset. Means apply and activate the current network dataset settings like channel, PAN ID, network key, etc., so that the device officially becomes part of that thread network. In simple terms, think of it like saving and locking in the Wi-Fi settings on your phone. Once you hit commit, the device starts using those parameters to join and operate in the network. The command thread star in the OpenThread CLI tells the device to actually bring the thread protocol online using the active dataset that you previously committed. In other words, after setting up and saving the network parameters with dataset commit active, thread start makes the device join or form the thread network and begin real communication with other thread nodes. You can verify network status using this command. Please read these notes for more information. Okay, so initial steps of our practical means creating thread devices and set up thread network via OTBR are completed. Now the next step is to add the Thread Matter Light devices in Alexa app. Our Amazon smart speaker will be acting as controller. Let's open an Amazon Alexa application on the smartphone. Switch to Devices tab. You maybe know this process. Here, you'll find already connected devices. And if you press this plus icon, you can add new devices. In next setup step, you should decide, choose, and select the type of your device which you're trying to add. From these all types of devices, like you can see here, light, plug, TV, camera, motion sensor, and so on. These are examples of standard smart home devices and commercial products. However, for this demo, we are not using any off-the-shelf device. Instead, we have programmed an ESP32 board to act as a Thread Matter Light specifically for this experiment. Therefore, to add such type of device, you have to choose this option. Other. Okay. On next page, you'll be asked about which logo you have on your device. And if you followed our previous introductory videos in this series, you maybe know that these all are modern smart home protocols, like Matter, Bluetooth, Zigbee, Wi-Fi, and Z-Wave. So we have programmed ESP32 as Thread Matter Light. Hence, here we have the select option of Matter. On next page, Alexa asks us that, does your device have a Matter logo? Typically, Matter or other off-the-shelf smart home products have these logos, which shows about their supporting protocol standard. Let me show you. Like this. So even though we're not using an actual commercial product, we are still using Matter. Just select Yes and continue. On next window, Alexa will ask us to scan the Matter QR code. So what do you think? We will get that. Yes, you guessed it right. We have seen that while programming ESP32 boards. Let's use that Matter QR code and add the respective device. Alexa will scan the QR code and tries to connect to Thread Matter Light devices through Matter Controller, which is our smart speaker Echo. During the setup, you might see a warning saying the Thread Matter device we're adding is not Matter certified. That's expected because, for this demo, we're using a custom-programmed ESP32 device, not an officially registered commercial Matter product with the Connectivity Standard Alliance. Ignore this and just go ahead. As our end devices supports Thread, on next screen, Alexa informs us that we have to first select and connect to the Thread network in order to add those devices into existing smart home network. If you have created the Thread network in OTBR setup, you will see that network listed here, like this. Select it and go ahead. Next screen is very important. As we mentioned earlier, here we have to add the credentials of Thread network, which we have been set up while creating it using OpenThread command line. The Thread network key. Enter that key. Here, like this. Then go forward. Once Thread Matter Light device get added successfully in Smart Home Network in Alexa app, you will see this message. Now, the next task is to give proper name to the device. Finally, you will see your device will appear here on Alexa Devices homepage, like this. Now we will add another ESP32 Thread Matter Light device, just to demonstrate the concept of thread mesh. Just follow along. And that's it. We've successfully added our Thread devices to the network. Now our ESP32 devices are fully integrated as Thread Lights. They form a thread mesh network and connect through the Raspberry Pi with the nRF52840 dongle, acting as the OpenThread Border Router. From there, the OTBR bridges the Thread network into our home Wi-Fi, where the Amazon Echo takes over as the Matter controller. This setup allows us to securely control the Thread devices either through the Alexa app or by giving voice commands directly to the Echo. Let's see the demo.
Alexa, turn on the thread light.
Okay.
Alexa, turn on the thread bulb.
Okay.
Alexa, turn off the thread bulb.
Okay.
Alexa, turn off the thread light.
Okay.
Alexa, turn on the thread light.
Okay.
Alexa, change color of thread light to warm white.
Okay.
Alexa, turn on thread bulb.
Okay.
Alexa, change color of thread bulb to white.
Okay.
Alexa, turn off the thread bulb.
Okay.
Alexa, turn off the thread light.
Okay.
So in this way, we have installed, set up, and tested the OTBR with ESP32-based thread end devices. In next session, we will see how to create OTBR using ESP32. Please stay tuned. If you face any difficulty in replicating our tutorials and DIY projects, feel free to ping us on Telegram or WhatsApp. You can also send us email at info@make2explore.com. We'll be happy to help. Thank you.